Okay, so this concludes the intro part of this meeting, and I'll start with the first keynote for today, which is about what happened during the last year. So essentially, if you were at the last user meeting and you got a pretty good idea of where we were, I wanted to give a small overview over what happened during this year. If you were at the hackathon, you noticed quite a bit of what happened, but I think it's still good to kind of summarize the year to give us an idea of where we stand now, and then with the talks and the discussions, we can think about where we want to go for the next year. So as I mentioned, we are nearly 10 years into Aspect, and what you see here is the Git commit history of Aspect over the years. It started, actually, this is the history that is on GitHub, and I suspect that the first year or so is not in this history. Oh wait, it started in October 2011, so it actually is the full history here.
There's a little bit more. I mean, maybe that's not important, but Aspect is cloned from the Steps 32 program, which is originally a copy of Steps 31. So if you wanted to go back, that's where it really comes from. But this is a good enough starting point, I would say.
Yeah. So this is essentially the first commit that was not longer in the tier 2 repository, but in the Aspect repository. And as you can see, over the past 10 years, there has been continuous development, which is really fantastic. And we also see the huge importance of the hackathons that we have every year. And even this year, when we had the first virtual hackathons, we created a spike that was very comparable to the hackathons before. So there are a few reasons to celebrate here. First of all, I wanted to congratulate Bob Myhill, who we heard already in the introduction, for becoming our latest principal developer. We already had a few new maintainers announced at the hackathon. I didn't put them up here again because I expected that many of you were at the hackathon. But since we actually have more people, maybe we should mention this again. So at the hackathon, we decided to expand the list of maintainers of Aspect. And we now have welcomed Anne Larum, Menno Freitas, and John Nalipov as maintainers of Aspect. All of them are here at the meeting. And we also decided after the hackathon to make Bob Myhill one of the new principal developers. And I just wrote a little something about why we decided that you would be a great addition, and your relentless pursuit of improving our thermodynamic mistakes really justified making you one of the principal developers. So thanks for all of your work over the years.
Thanks, René. They're now much better mistakes.
Yeah, the mistakes are now much better. Yeah, much more complicated.
Yeah.
Also, we can celebrate that we had a pretty successful first virtual hackathon last summer, despite all of the complications due to the pandemic. We are very happy about how everything went. We had 15 papers last year using Aspect, so that's great. We have a pretty continuous growth in the number of papers every year. And this is possibly an undercount. We don't know every paper. This is also, we would like to ask every one of you, if you publish a paper that is using Aspect or comparing something against Aspect, then please let us know. As, of course, the first step is to cite the papers that Aspect lets you know about which papers to cite. But also please maybe drop us an email because it helps us justifying the work that we put into Aspect. And all of this points to the fact that we have managed to keep Aspect alive for 10 years and continuously grow the community and the activity around it. So I just want to give a quick summary of what happened over 2020. So last January, we had the first virtual user meeting. As I mentioned, we had 35 participants. We had planned it for 2 days, and each day had 3 blocks of 90 minutes each. We had discussion topics, in particular about the repository structure, the structure of the manual, whether to have separate folders for teaching materials, for how to generate a subduction cookbook that we are currently still missing, which would be great to have. So we heard from you already that we have a number of people working on subduction models. If you have any model that is reasonably simple and can be used as a subduction cookbook, then we would be very grateful to just, if you could send us a parameter file and maybe a page of text explaining what is happening, that would be awesome. Or open a pull request to the GitHub repository. We're still looking for a good subduction cookbook. And then at the last user meeting, we had quite a bit of talk about the GMG preconditioner, so the new Stokes solver and aspect that was developed by Konrad, Timo's postdoc, and Timo. That is now part of Aspect and significantly faster than the current Stokes solver, or the old Stokes solver, so to speak, but somewhat limited in which models can be run with it. So I'll get back to that in a few slides. The topics at the last user meeting were the Stokes GMG that I just talked about, viscoplastic rheology, free surface, and the geodynamic world builder. And we had 6 short presentations: viscoelastic free surface, melt models, anisotropic viscosity, dynamic topography, benchmarking the advection solver, and using web-based data to start an aspect model. If any of these topics are interesting for you and you missed them last year, the talks are still available if you go to this address, and maybe I can post this in the chat. Just in case you missed them last year. Sorry, this didn't go out to everyone. There's the link in the chat. We got very positive feedback, and this is why we do this again this year, because so many people told us that this is useful for them to get to know what other people do. We listened to the feedback that it's good to limit this to just half days, which is why we limited to 2 sessions this year, 2 90-minute sessions, and a 3rd optional session if you want to meet with anyone specifically. And we had the introduction slides this year that we did not have last year. So this year will be slightly different. We will have more short talks and less longer keynote talks, which will hopefully be interesting because we see a wider variety of topics. And we spent a bit less time overall, but scheduled this time for individual meetings after our talks. Then the other big thing in 2020 was, of course, the release of Aspect 2.2. You can see the full release notes on GitHub. And since then, we had a few major changes. We had a few changes that changed compatibility with DO2, for example. After the release, we dropped the support for DO2 9.1.0. So if you run a latest development version, then you will need DO2 9.2. One of the major changes that was made after the release is that we can use new CMake functionality to speed up the compile time of Aspect significantly. So if you had problems with the release or earlier that compiling takes too long or influences the productivity of Aspect for you because you have to wait for compiling longer than you can actually run and test models, then this should be fixed with the latest development version, as long as you have a CMake version that is sufficiently new. And then there was the 2020 Aspect Hackathon in August. This was, as mentioned, our first fully online hackathon, and we were a bit worried initially how we could make this work, whether it would be as productive and helpful as the earlier hackathons. We had 25 participants, we still limited the number of participants because we felt that it could get out of hand if the meeting becomes too large, that we couldn't provide the individual one-on-one support and time for discussions. It was mostly distributed between Europe and the US, and we had 3 core hours every day. We met daily, and outside of this time, everyone would work whenever it was useful or it worked for them. One of the results of the hackathon is our new logo, which you may have seen already on the webpage, which replaced the older logo from the very beginning of Aspect, and is also now fully reproducible, so we can rerun this model and get this figure again. Another result of the hackathon, as already mentioned, was that even in virtual meetings, it's important to have social activities. And we had a Slack channel that was dedicated to the work during the hackathon. And we had one Slack channel that was dedicated to after work or social activities. And the amazing care package that was sent out by Lorraine proved to be a very important part of these social activities. In particular, the scavenger hunt with the dinosaurs was very popular, and we had all kinds of interesting dinosaur activities in the launch channel of the Slack. I tried to go through the Aspect Hackathon log and put out the most important changes which are not already covered in some of the talks later during this meeting. So apologies to everyone who I may have missed. These are just a few things that may not come up again in the talks later during this meeting, but I think would be interesting to highlight as new features and changes in Aspect. First of all was the addition of a surface deformation plugin that allows to diffuse the surface. So this is a very simplified approximation of a surface process models. We have already seen much more complicated, much more sophisticated approaches like coupling to other codes. But for simple surface processes like pure linear diffusion, we now have a plugin that can handle that even without coupling to other codes. We have a functionality to heal strain and strain-dependent rheologies. This is used in the strain-dependent rheology plugin, and therefore, for example, in the viscoplastic material model, if you're interested in strain healing rheologies. We have a lookup for stable phases at different pressure and temperature conditions. This is an extension of the ability that we had before to look up material properties from a property table. Now we can also look up the stable phase, which can, for example, be used to modify the rheology independence of the stable phase. There are now periodic boundary conditions for 2D quarter shells. So we had periodic boundary conditions for boxes before. The modifications that were necessary for the quarter shell were made during the hackathon by Q&ARene and Timo and myself. And this also now works for particles. Although just last week we figured out that they're using particles with periodic boundaries and shells is currently slow. That should be fixable soon, but it's correct. It's just a bit slow at the moment. We have a new structure to manage mesh deformation. So this is not longer limited to just the free surface, but in theory, you can prescribe all kinds of mesh deformations as long as they are small. And these plugins now, since the hackathon, also support initial deformation, which means you can create models like these, where you start with an initial deformation and then you deform the surface according to any kind of function or any other process that you can implement as a plugin. Also, there has been significant progress in supporting particles and deforming meshes. It's not quite finished as far as I understand at the moment, Anne, but we are very close to finishing the full support for particles and deforming meshes. And this new type of plugin will replace the initial topography plugins that are there at the moment. So if you currently use an initial topography, then you may need some changes for one of the future aspect versions once we phased them out, because we previously we had essentially two separate systems to define the initial topography and then later deformations of the mesh, which caused some problems with the mesh refinement. And so we decided to unify that into one system, which will be in the mesh deformation plugin system. And again, sorry for everyone that I skipped over at the moment. The full report for the hackathon is available online. If you want to see all the changes that were made, I will post the link into the chat. I think it's a 20-page document or so with all of the larger and smaller changes that were made. Okay, I just have a few more notable features of 2020 left, and then we can get to some discussions, and then also we will have the science presentations in the next block. First of all, there were new additions and scaling tests for the GMG solves preconditioner in the last year. We don't have a full talk this year about the GMG solver, but maybe Timo, do you want to say a few things about the slide, or should I go ahead?
I can do that, yeah. So this has been a longer development by my former PhD student and former postdoc now, Conrad Clevenger. And the goal of this in the high level is to replace the Stokes solve, where you solve for velocity and pressure, which typically for at least three-dimensional models takes significant amount of time and memory to do, and to improve this. And the current state is that a lot of this is inside aspect and working well, but there's also a lot of caveats. But I guess the more recent thing is that you can now use this also for defect correction PCAR. So Newton, the Newton option is still not working, among some of the other things. But I guess the thing to remember from the scaling, and if you can look at the paper that we submitted, you can find it on my website about this. There was also a news article about this a while ago. But basically, the things to remember is it's about 3 times faster and uses about 1/10 of the memory compared to the old solver. And so you can run potentially 10 times bigger models, and you can run them 3 times faster and better scaling. So the limitations that Rene lists here is Newton solver doesn't work, free surface doesn't work, two-phase flow doesn't work, and there are some restrictions with boundary conditions. So not only periodic and traction are difficult or impossible, there's also other situations with no normal flux in chunks, for example. So there's some limitations there that we're aware of and that we are working for. But the idea is that this eventually will become the default solver to use. And if you can use it, I would strongly recommend that you take a look at it and try it out to see whether it works for you.
And we have a few test models that already use it in the repository.
That's right.
Timo, is there a benchmark or cookbook model that already uses this solver?
So the tests that you see here, the scaling plots, are run with the NSyncer benchmark. And there's, I'm pretty sure there's a file in there that you can run with the GMG. And my goal for the next few months is to do some of the official timing benchmarks on the machines and also add a matrix-free version of this so we can actually see and compare results.
Okay, sounds good. So the modifications to the parameter file are pretty minimal, and you can find it either in one of the tests that are labeled GMG or the NSyncer benchmark case. And then there is also a new time stepping logic, and I'll just hand it back to Timo.
Thanks. Sorry for taking over your presentation.
No, that's fine.
So I'm not sure how of a major topic this is, but I decided to, this is a project I've been working on and off for the last couple of months and during the last online workshop, etc. And the goal is to rework how time stepping works in Aspect. And I made these slides and realized I have more slides than expected, but I thought it's useful. Even if you don't care about the new features, I think it's also good to understand how time stepping works inside Aspect, right? And so the goal of this rewrite was to let the user or user code actually control the time step size, because for now there are some knobs you can change, but overall Aspect decided or decides by itself how big of a time step to make every single time step. And a second goal was that some people wanted to potentially reject a time step and repeat the last one that we just executed based on some criteria, right? So for example, you need to resolve a certain feature in time and you only know after solving exactly whether you did resolve this or not. The third thing that ties into this that I was interested in is that I want to be able to trigger mesh refinement due to certain events when I want to resolve something. And then also combine this with potentially rejecting a time step. So imagine the situation of the picture on the top right. This is like a shear band test. So imagine that you solve a time step and you developed a shear band at a certain place. And then you realize, oh no, I didn't resolve it fine enough on my adaptive mesh. So what do? You want to trigger refinement to resolve it. And then you want to go back in time and repeat the time step, maybe with a different time step size, maybe with the same time step size. And then now you're resolving the shear bands correctly. That's the idea. The fourth thing that people might want to do with this new thing is to react to nonlinear solver failures. This is not quite there yet, but that is also something that might be interesting, right? You have a nonlinear solver, it doesn't converge, and then you could activate a setting that says, well, maybe I retry the solve with a smaller time step size, for example, if that helps in your specific. So the summary you see here is the new logic that gets executed at every time step. So the first thing is we execute, so step one, we execute all the time stepping plugins that are there, called execute, and the plugin returns a time step size, a desired time step size, and then we take the minimum over all of them. I will list some example for time step sizes in a minute, right? And so in your parameter file, you see that at the bottom right, there's a new time stepping subsection, and you can just list the model names that you want, right? And the default is to use the convection time step. I'll define what it does exactly in a second. The second one is there's a bunch of options that need to be applied and need to be guarded against. So for example, we have a minimum and a maximum time step size. We have a maximum increased time step size. We have a maximum first time step. We have the situation when we know we want to end at a certain time that our last step actually hits the end exactly. So these get applied after this. So first all the plugins, take the minimum, then apply all these other rules that you might potentially have. And then there's a third phase, which is way different than what it is before. Basically, you ask all the time stepping plugins whether they're happy with this, right? So each of the plugins get a second chance to say, do we want to repeat the time step? Yes or no? If you want to repeat, what size do you want for this? And the second one is, should we do a mesh refinement right now before we move on, right? And so you can imagine that with these reactions, you can do potentially all these four things that I listed up there as goals, right? So if you can express it as a code that does this logic, this fits into the system and you can use that. And we have some early tests that show that this works. Okay, next slide. So I give you a very simple example, is you can manually control the time step. Like if you say, I don't want anything to do with the automatic time step control, might not be a good idea, but sometimes you might want to do this, right? So you just say time stepping, list of model name as function, and then you write a function expression where you return the time step size as a function of time, right? And so this is the test. This is in your the Aspect development version under time stepping function, and it has a weird, if time is less than 1, then this, do a cosine, otherwise do a linear time step size in the pictures on the right. Okay, next slide. So this is a more complicated example, and that's also a plugin that's part of the development version. It's called Repeat on Cutback. And what it does is it repeats a time step with a smaller time step if the time step decreased by a large amount. Sounds complicated. The idea is the following. You have a boundary condition, for example, that very suddenly changes the whole behavior of the solution, right? So for example, velocities increase and suddenly your time step needs to be much smaller by default, right? And this event might happen at a certain point in time. And if you do your normal time stepping, you kind of miss the event, right? So or it is delayed and you don't resolve it nicely. But what if after you do the time step and the time stepping says, oh, wait, your time step needs to be much smaller, then you say, okay, instead of continuing, I go back and I repeat the time step with the smaller time step size. And this might be a special case and you might not be interested in this, but I'm showing you the code down there on the right. This is the whole code of the plugin, right? It says in the execute, it says I'm returning double max, so I'm not giving you a time step, but I have an implementation of determine reaction. And what I do is if the next time step is smaller than a repeat threshold of the last time step, then I say repeat with following step size, and otherwise I say advance. The code might look complicated, but it's really just this if logic basically, and it's enabled by the new plugin. And there's also a test for this. It looks like I forgot to put the name of the test on the screen here, but you can find it also under this name. Okay, next slide. And then this is the current state. So the current plugins are convection and conduction time step. These are the ones that are the old ways you could use the time stepping. I'll explain them in a second. And then the other two are function, I explained that a minute ago, and repeat on cutback, I explained that a minute ago. And then user plugins, you can write your own, right? And so the default in Aspect used to be convection time step, where it basically means that information travels at most one cell. So we look at the velocity in each cell, and we look at the cell size, and we determine the time step size for the next time step so that the information doesn't travel more than one cell. And you can modify this with the user parameter, the CFL number that you might have seen, that you can use to change how big the time steps are that Aspect takes. And this ensures that when you refine your mesh, you make smaller time steps, and it ensures that you don't have a plume that basically runs out of your refined area too quickly if you use mesh adaptivity. But it's not required to use that. So that's for convection, right? The second, this is optional, and I think it is not enabled by default, is that we also can obey a timescale that makes us or allows us to resolve heat conduction. And so this depends on the physical parameters and the local mesh size. Formula is written there as well. So you can combine any of these, right? The default is convection time step, so nothing has changed in the default, but if you want, you can combine them, right? You can, for example, add a function that you use for a certain time range where you want to have a certain time step size, and then later on, maybe you want to use the convection time step only, for example. And yeah, so for the future, what we are talking about, and which I don't know if we have time to talk about this in the next 2 days, but at some point we need to have the conversation about how do we want to use this to react to nonlinear solver failures? And do we want to abort by default? Because right now we don't, right? Right now, if a nonlinear solver fails, some of you might know, we go to the next time step and we just ignore it, which is probably not the right choice. And the other thing that I still am working on is the example with resolving shear bands. It's actually harder than you might think it is to do the mesh refinement reliable to be able to resolve things. I think that's all I have for this. So I'll give back to Rene unless there are questions.
Thank you. If we want to discuss the time stepping, I would say we are nearly at the end of the first time block that we allocated. And the next time block will contain 45 minutes of short presentations and then 45 minutes of discussion. So that would be a good time to delay discussion until then. But if you have any short questions about this first keynote, either the time stepping or anything, any of the features that I mentioned before, then feel free to ask them at the moment. So right now.
I would have a quick question.
Sure.
That's amazing to see what's happening, Timo. So in the beginning, you showed this image of this share band, and you said that it's working, and in the end, you said it's not quite working. So what's the status on this?
So I reported on this, and I have something working on my computer for this specific example. This is not a ready-to-use thing inside Aspect at this point. So yeah, I don't know how I would make this available and how this is generally usable, right, by everybody. But the functionality is basically there.
Okay, thanks.
Okay. So in essence, this was the view back towards 2020. What happened in 2020 and where are we at the moment? Now it's 2021. And so one of the questions that we would like to get to at the end of this meeting is essentially what are the things that we want to do in 2021. So keep that in mind during this keynote and then during the other presentations this afternoon and tomorrow. What are the things that you would like to work on in 2021 and what are the things where we need to make progress to make Aspect better? So now we have scheduled a half-hour break. Depending on where you are, that might be your late breakfast, your lunch, or your dinner break. And afterwards, we'll hear 3 short presentations and then have time for discussion. If you want, feel free to stick around. I will leave the Zoom open and you can discuss any topics that come to mind. As I mentioned, the whole meeting is recorded, but we will only upload the presentation part. We will not upload discussions or the breaks, so don't worry about the recording part of this meeting. With that, for now, thank you for being here for the first part, and see you all in half an hour.